so I think we're going to record this, right?
It's
Being recorded. Excellent. All right. So I'm pleased to welcome Nate Brown to our virtual Crmse Colloquium. He was trying to schedule a work vacation kind of thing where you come out with his family and spend a few days. But anyway, we're super glad, Nate, that you were able to organize it anyway virtually. So Nate is a theoretical mathematician committed to equity and inclusion in STEM education. I guess, how many years has it been since you turned your interest to educational research? Maybe 5 or 10?
Five, 6, till it was genuine. Yeah, about that.
One of the things that he works with or runs the STEM diversity lab at Penn State, and his lab is currently developing a valid and reliable measure of inclusive instructor behaviors in undergraduate math classes. And interestingly, we're going to be using those items in research work we're doing this semester at San Diego State. And Colin McCraney is on the call now. He's working to incorporate those items into a survey he's developing for our pre-calculus and calculus courses. So we're looking forward to continuing to work with Nate. I first read about some of Nate's work in this large prestigious academy study where they looked at that how STEM courses disproportionately weed out underrepresented students. They've also looked at differential impacts of COVID pandemic on race, ethnicity, sex, and socioeconomic status, and among other things. And I'll just turn it over to Nate and let him share some of the great things he's doing.
Oh, wait, I just spotlighted us late. There we go. Spotlight Nate. Sorry about that.
No worries. No worries.
There we go.
So yeah, so thank you for that wonderful introduction. It's a real honor to be here virtually. So thank you for having me, but I have to say it's also a little scary to be here because I'm not an expert in education, at least not yet. I'm working on it, but there's a lot to learn. And my expertise is in theoretical mathematics, C-star algebras, von Neumann algebras, non-commutative probability. I spent 20 years publishing theorems in these areas. But as Chris said, now my research focuses entirely on equity in STEM education, or rather in equity in STEM education. And, you know, I've always loved teaching and I've taken it very seriously, but to understand this new line of research and really, I think why I'm so passionate about it, I hope it'd be helpful if I sort of help you understand what led to the change, because it took many years and it involves some pretty humbling experiences. So if you'll stay with me for a bit, I'd like to spend a few minutes telling you how I got here. So maybe the story begins in 2010. I was on sabbatical, and the institution I was visiting, they needed someone to teach a math class for their elementary ed majors. So, you know, the undergrads who go on to become teachers at our elementary schools. Now, I was used to teaching math majors, graduate students, so this seemed like an interesting change of pace. Plus, both of my daughters at the time were in kindergarten. So I was pretty excited to teach math to their future teachers, right? So I happily accept the gig and, you know, I start to learn about this institution's math for elementary ed course. And well, it turns out the course was, shall we say, unique. It had been developed by one of their theoretical research mathematicians who completely rewrote the curriculum according to what he believed future elementary school teachers should know. Now, this man was 100% invested in the course. It was his baby. He literally wrote the book that was used at that institution. And he had the best intentions. He was a wonderfully kind man who cared deeply about students and mathematics and math education. But there's really no nice way to say it. It was the worst course I've ever seen. It literally started with group theory, though he didn't use those words, but that's what he was teaching these elementary ed majors. And if you're wondering what group theory is, you are not alone. Unless you were a math major, because this is material that undergrad math majors typically see in their 3rd year. Very few non-math majors ever see group theory. And he genuinely believed future elementary school teachers should know this. I mean, this is like introducing organic chemistry or quantum mechanics in a course for elementary ed majors. I was just stunned. But I was also on sabbatical, and I didn't want to develop my own curriculum, so I used his book and I did my best, and it didn't go well. Students did their best too, but they weren't prepared for group theory any more than they'd be prepared for quantum mechanics. And they really couldn't understand why on earth they were forced to learn this stuff. Those poor students, they wore their suffering on their sleeve. The pain was palpable, like I literally could see it in their faces. And remember, these were my daughter's future teachers, and I was responsible for that palpable pain that I was witnessing. So that wasn't too fun, but something else happened in 2010 that would have a huge impact on me eventually. A remarkable paper was published in the Proceedings of the National Academy of Sciences. Researchers were studying math anxiety in an elementary school context. And they wondered what happens if a first or second grade teacher has high math anxiety. Specifically, they wondered if a teacher's math anxiety would be reflected in the student's math achievement. Right? That was the research question. Does a teacher's anxiety impact students' achievement? Well, as you might guess, the answer is yes. But it's not uniformly yes. Right? It's not uniform across the classes. When the teachers in this study had high math anxiety, the little boys in their classes weren't significantly impacted, which, among other things, means the teachers were doing a great job teaching the math. It was getting through to the boys despite their anxiety. It was only the little girls who showed decreased math achievement, which means that the boys and the girls in those classes were not having identical experiences, even though they're literally in the same class. And the researchers suggested, as this wasn't they weren't able to test this in their study, but they suggested, based on other research, that one explanation might be because in first and second grade, almost all teachers are women, and research shows that children are more likely to emulate the behaviors and attitudes of same gender adults. Girls tend to emulate women, boys tend to emulate men. So put another way, when an elementary school teacher has high math anxiety, it's more likely to be picked up on and internalized by their students of the same gender. And that's why the math achievement of the little girls suffered while the little boys didn't. So let me summarize, right? It's 2010, I'm on sabbatical, essentially torturing future elementary school teachers with group theory. And I learned that any trauma I cause in that class is likely to be passed on to our daughters, but not our sons. Well, I wish I could tell you that that was the pivotal moment and I committed right then and there to learning everything I could about education, teaching, equity, where I became the very best teacher I could possibly be. But that's not exactly what happened. What happened was I tucked those uncomfortable thoughts into the back of my brain, and I continued proving and publishing theorems about C-star algebras. Because let's be honest, math research is the only thing that really matters to a math department at a large research institution like Penn State, or I assume San Diego State, right? There's no incentive for me to go out and learn to do something better. So I wish I could tell you I handled it differently, but the truth is I put those things in the back of my brain and I just kept doing the things that Penn State rewards me for. But of course, tucking uncomfortable things into the back of your brain, it doesn't eliminate the discomfort. It just sort of sits there and festers and grows, right? And over the years, these uncomfortable thoughts, they'd occasionally reemerge. So I did start to learn a little bit about better teaching, active learning techniques. I started to experiment. I gradually moved away from traditional lecture and did some more in-class group work. one of the first things I really started to do was try to be intentional about sending growth mindset messages, building confidence in students. But still, I was more or less, teaching very similar to the way I always had done. And I wasn't learning about education research, equity research, and so on. But then in 2016, another study came out, stunning paper. This was actually co-authored by your own Chris Rasmussen, by the way. And this time I couldn't just tuck these findings into the back of my brain. You see, the 2010 study, this only applied to me because I was teaching elementary ed majors at that moment, right? I haven't taught that class since, so it was easy enough to sort of push those results to the back of my brain because they didn't apply directly to me. And it's easy to be apathetic, right? When injustice doesn't touch our life directly. But the 2016 study, that was about college calculus, something I teach every year. And Chris and co-authors, what they found was that women are 1.5 times more likely than men to leave a STEM major after taking college calculus. Engineering, chemistry, biology, all these disciplines lose more women than men after calculus, the course I teach. And this just scared the hell out of me because I can't live with myself if I'm contributing to gender inequity in STEM education. I can't look myself in the mirror and say, but I'm a good teacher and I love my students. I have the best intentions. I want all my students to succeed. I mean, those things are all true, but my best intentions or my genuine love of my students does not matter. It's completely irrelevant to students who are being harmed in my classroom. I mean, I think of it as sort of like the difference between accidental manslaughter and premeditated murder. I mean, this is an extreme analogy, but I hope the point will come through, right? Manslaughter and murder are not the same thing. The intent is totally different. But to the dead person, manslaughter and murder, they're the same. And that's sort of how I see equity in STEM education. It doesn't matter what I think about education or whether I love teaching and have the very best intentions. To my students, the thing that matters is how they experience my class. It's not about me, it's about them. And this simple act of decentering changes everything. So it's 2016, and I finally faced a very uncomfortable truth, right? I've always been a passionate, caring, committed teacher who knows a lot about research, theoretical math research, and almost nothing about equity in education. And it really bothered me that ignorance may very well make my classroom a source of inequity. So I decided to transition from math research to equity in education research. And it has been incredibly hard, incredibly humbling, and incredibly meaningful. I wish I'd made this transition sooner, but all I can do now is commit the remainder of my career to dismantling the structural sexism, racism that pervades higher STEM education. And of course, many of our colleagues have been at this for a long time. I'm definitely late to this party, but I hope everyone doing education research, if you're not already at the party, please come join us. It's a great party. It's a lot of fun. So that brings us to the research part of my talk. So let me share my screen real quick and we'll pull up some PowerPoint slides. Are those coming through? All right, beautiful. So yes, as Chris mentioned, I'm here to talk about our current project, which is inclusive instructor behaviors. But I want to provide a little more context to this project. So I'd like to start with the paper that Chris mentioned. It's absolutely inspired by the 2016 paper. We were really trying to sort of replicate and extend that work from an intersectional perspective. And so let me set up that paper that we published last fall. So consider the following. Imagine you have two first-year college students. They show up to San Diego State University, bright-eyed and ready to further their education. These two students have identical GPA, high school GPA, and ACT. And in case you're wondering why we chose those particular numbers for our hypothetical students, it's because both of our students declare a STEM major when they come into college. And that GPA and that ACT, those are the averages of the STEM majors in the data set we are using. So you're really looking at prototypical incoming STEM students. All right. Well, in addition, in their first semester STEM courses, the sort of weed out courses, math, chemistry, intro bio, whatever, these two hypothetical students get C's or better in all of them. So they survive their first semester weed out courses. And the question we wondered was, what's the chance that, 4, 5, 6 years down the road, these students actually get a STEM degree? And the answer, if you're a white male, is 48%. And if you're a Black female, the answer is 28%. And this is, to me, just a shocking and horrifying disparity. Not entirely surprised, and I confess I was surprised by the magnitude of the disparity. I really was hoping it wouldn't be that big, but that's what we found in our data. So this work is based on a midfield data set. We used 110,000 students. We have actual transcripts, complete transcripts for all of these students. They all come from large public research intensive universities, places, like Penn State. And so these are, the kids I'm seeing, the kids you guys are seeing every single fall. And these disparities, as I say, are well, for me, they're just horrific. And so we have to do something about this. We can't unring this bell. Like, we know how bad it is. We have to do something. And no doubt there's going to be a lot of things that are contributing to this disparity. It's not going to be, a one-dimensional problem. There's going to have many dimensions to the disparity of this type. But we have to be real careful when we start to try to figure out what's going on. We cannot blame K-12 preparation, because the students in our profile had identical high school GPA and ACT scores. We cannot blame this disparity on, differences in interest in STEM between men and women or whatever. We can't blame, because they came in with a STEM, declaring a STEM degree. And we can't blame first semester grades, because they both survived all of their intro weed out courses, STEM courses. And this leads me to a very uncomfortable conclusion, right? Because if we were in an equitable higher STEM education ecosystem, right, if it was genuinely a sort of level playing field in college, then when two students come to you and they have the same high school preparation, interest in STEM, grades in their first semester, we would expect that they have similar probabilities of graduating, and they don't, which means that we can't be in an equitable system. So my only conclusion from this is that the ecosystem in which we are all operating right now is contributing to the structural sexism and racism that has been so well documented in other contexts of our society. So I want to know what we can do about that. We faculty, right? How can we start to critically analyze, dismantle these structures, these structural inequities? And that's what my whole project is about, inclusive instructor behaviors. But before I get to that, I want to present one more study that quite clearly shows one of the ways that faculty are contributing to structural inequities. And this was a very impactful study for me personally. And so this one is focusing on faculty. How are faculty contributing? What are some of the many ways that we might be contributing? And this has to do with the beliefs of faculty. So I'm just going to recall for you the definitions of fixed and growth mindset, because we're thinking of faculty now. What do faculty believe? And a lot of faculty, especially in math, actually math and physics, math and philosophy tend to have the highest percentages of faculty with this fixed mindset. Anyway, the fixed mindset is a belief, a worldview that talents and abilities, whether it's intelligence, whatever that means, these things are mostly fixed. They're sort of imprinted in your DNA at birth. There's not a lot you can do to change your talents and abilities. And if you hold this mindset, then failure, it just reflects a lack of innate ability. You just don't have it. Now, the reason you failed, you probably just don't have what it takes. That's the way someone with a strong fixed mindset may view things. But that's not the only way to think. It's not the only belief that you can have about talents and abilities. A growth mindset would see this as a case where most abilities can be acquired with enough effort and training. And here I have to be quick to point out most, right? Growth mindset does not suggest that everybody can become a professional basketball player. That's not a typical ability, but I personally would put something like calculus in the most abilities category. I will never, ever believe that calculus is more difficult to learn than a language. And we all learn a language. It takes a long time. It's not quick. But I personally do put calculus into the most abilities category. And I genuinely do believe that that can be acquired with enough effort and training. But we don't really do that. We don't really offer enough time and training to learn those things. But anyway, when you take this worldview, then failure just means that we need to practice more. It's not a statement about your DNA. It's a statement about your training, and that we can do something about. Okay, so the question that is addressed in the study that I'm about to present, right, is whether an instructor's mindset is reflected in student grades. It's sort of similar to the math anxiety study that I mentioned at the beginning, the 2010 study. But this time we're looking at STEM instructors. We're looking at higher ed, not elementary school. And what they found, sorry, let me give you some statistics here. So in this study, they were looking at about 15,000 students' grades in STEM courses. This came from about 150 faculty instructors, STEM instructors in college. And so they took the instructors, these 150, and they sort of categorized them as a strong fixed mindset, strong growth mindset. And then they looked at the grades that the students in those instructors' classes got. And they find that the grades of their students are reflected in the two different mindsets of the instructor. But it's most pronounced when you look at underrepresented students, so Black, Hispanic, or Native and Indigenous students. When the instructor holds a strong fixed mindset, a typical URM student got a B- in their class. And when the instructor has a growth mindset, a typical URM student got a B. So this to me is a very disturbing but important study that shows one of the many ways that faculty may be contributing to structural inequities. And again, this really hits home for math, because in mathematics, us and the philosophers apparently are where we find the highest percentages of faculty that hold a strong fixed mindset. Okay, so what are other ways that faculty may be contributing? And that really is the subject of the work that I'm doing right now. I am most interested right now in looking at how faculty might impact some psychosocial variables. Specifically, I am looking at two student-level psychosocial variables: sense of belonging amongst our students. So how do our students feel, right? Are they feeling secure? Do they feel supported? Is there a sense of acceptance and inclusion, identity when they're in a STEM context? And the other is self-efficacy. And here I have to probably say from the beginning, I'm still not entirely sure what the difference between self-efficacy and confidence is. So I've been told those aren't synonymous, but I very well may interchange them in this talk, because as I say, I'm still not entirely sure what the difference is. In any case, Self-efficacy is belief in one's capacity to be successful in STEM. And as I say, what I'm really trying to study right now is how we faculty might be impacting students, sense of belonging, students' belief in their capacity to be successful. So why am I focusing on these two variables? Well, a few years back, I don't know, been 5 or 6 years now, the National Academy of Sciences released this report that I show there. And one of the many things they do in that report, they review the literature that shows that both belonging and self-efficacy are quite malleable. And let me just give you a quick example to illustrate this. And there really is research behind it, but I don't think we need to see it to believe it. Let's think about belonging for a second. And imagine you go to a party. And imagine you don't know anybody at the party, but you've been invited. And so you show up. And you open the door, and there's a bunch of people. They're all talking. They're having conversations, right? They see you walk in. They stop their conversation. They look at you, and then they go back to their conversation. Nobody even acknowledges you, right? How's your belonging at that party? How are you going to feel? Are you going to feel welcome? As opposed to you go to the same party, right? You open up the door, somebody looks at you, somebody walks over like, oh, hi, how are you? Who are you? You know, where can I take your coat? There's the snacks, there's the drinks. We're very glad you could, right? Belonging is a very, very malleable variable. And the point here, from my perspective, is that if we have malleable variables, student level malleable variables, then as instructors, we have the capacity to increase or decrease, you know, to sort of turn the dial on those variables. And so these are places that I'm very interested in studying. The other reason, though, or one of the other reasons that I'm so interested in these two is that both belonging and self-efficacy are associated with student outcomes, grades, persistence, etc. And so to me, when I think about what an instructor can do to increase or decrease student success, when we think about variables that we can turn the dials on that are malleable and which are associated to student outcomes, those are prime places for intervention, right? Those are prime places where we instructors can hopefully increase the variables in a way that is reflected in student success, however you choose to measure that. And here, I just want to give a shout out to this little resource. I've been to this webpage so many times I've lost track. Anyway, this is a great resource for things around mindset and belonging. Their little tab on research and resources is wonderful. It has a long list of the actual research papers, even some syntheses. So I'm just advertising this wonderful website if you haven't already been there. Okay, well, so I talked about malleability and association with student outcomes, but there's actually another reason that I'm really focused on belonging and self-efficacy, and that's just pragmatic. It's just a pragmatic reason, because I'm sure if any of you, or those of you who have been involved, you know, in trying to talk to people about better teaching, how to become a better teacher, how to, you know, increase whatever dimension of education you're interested in. Oftentimes what you hear is, yeah, but it's just so much work to learn an active learning technique or to learn mastery grade, right? It's so much. And that really would have resonated with me even just 10 years ago. So another reason that I'm so interested in these two variables is that you can go in tomorrow into your class and start to promote belonging and self-efficacy without changing a single thing in your class. You don't have to change a thing. You could walk in tomorrow and start to say things like, y'all belong here. Y'all belong here because you have done what you're supposed to do in high school. You did what was asked, you learned what you're supposed to do, and you have the capacity to be successful in this course. And then you can give them the same exam that you wrote the day before or whatever, right? These messages don't require any other changes. Now, I certainly hope we won't stop there, but as I say, this is a pragmatic reason that I'm sort of really focused on these variables, because there are things you can do and they can be impactful without changing anything else in your course. I will say here, anecdotally, from my students and others, it is super important that if you decide to do this, if you decide to send some of these messages to your class, that it be authentic. Students are very tuned in to BS, and they've told me this, right? In our focus groups, actually, this came up. If you are saying things and you don't really believe them, they will pick up on it. So anyway, if you choose to do this, please make sure you are being authentic, and also you need to repeat it often. It's not the sort of thing you can just go in on the first day of class, make this claim, and then believe that everybody's belonging and self-efficacy has been impacted. That's just not how humans work. In any case, here's a very light lift that we can all start to do. And I do want to illustrate for you before we get into the deep dive in the research, just how impactful this can be. About 2 weeks ago, I got an email message from a former student. Her name is Taylor. Taylor wrote me and she said, just found this, your original note faded a bit, but I rewrote it. Just thought you'd appreciate knowing I've held on to this for encouragement for 10 years. And I didn't know what she was talking about. That was the entire message, but there was an attachment. And so I click on the attachment, and what comes up is a pic of an exam that she had taken 10 years earlier in my class. And I had handwritten a little note at the bottom of her exam. And what she's referring to here, the ink that I used had faded, so you couldn't really read it, but in big, bold, black ink, she had rewritten the note that I left on the bottom of her exam. And this is what I wrote. There's a reason you're in this program. You're smart. And when doubt fills your head, remember how far you've come, and remember that I believe in you. That cost me nothing to write that. I didn't have to change a thing in my class. And it was incredibly touching to get this feedback 10 years later. And again, this is just to illustrate how impactful it can be to do some of these messagings. Because, I've interact with a lot of students and get feedback from them. And I've never once had a student write me 5 years after the fact and be like, that think, pair, share thing, man, that was really impactful. That, the group work that you did, like, I've never gotten those messages, but I do get messages like that. Taylor's not the only one. So anyway, I think these variables are really important for us to think about, for their malleability, for their associations, and for their potential impact and the light lift that it can require to send positive messages to our students. Okay, so what are we doing more specifically? What we are doing now, we're trying to develop a measure of inclusive instructor behaviors where inclusive is operationalized as promoting belonging and self-efficacy. We have taken a grounded approach. There is no measure out there that I'm aware of that gets at these things. And so we took a grounded approach. And so just sort of roughly, when you're developing a new measure and you take a grounded approach, the first step is going to be to go ask your students, do some focus groups, interviews, whatever, and ask your students, what does your math instructor do or say that makes you feel you belong and can succeed? And then you take everything that you hear from all the students, all the behaviors, they're kind, they're patient, they're not patient, whatever they say. And you put them all into a survey. And then you distribute it out to a bunch of students to have them fill out this survey. My instructor does this, doesn't do that on Likert scale or whatever. You do exploratory factor analyses, item reduction, and then the final step is to take the reduced instrument, the one that you believe is the right one after exploratory factor analyses and item reduction, collect more data, do confirmatory factor analyses and validity studies. We are basically finished with steps 1 and 2. We're still writing up step 2, but that part is done. And we're actually in the process of collecting data for step 3. And as Chris, I'm super grateful for the help we're getting from Chris and Colin to help collect data for the confirmatory factor analysis that we hope to do soon. So I want to unpack a little bit our methodology here because, as I hope my story at the beginning suggests or makes very clear, I'm not coming into this from an education perspective so much as from an equity perspective, right? I am very motivated by social justice and inequity. And so my methodology reflects that. And so I want to talk a little bit about that. So I didn't really know this word at the time, quant crit, or this concept, but the people I was working with did, and my mentors. And so they didn't try to throw everything at me at the same time, but the methodology that we used apparently falls under this umbrella. So quant crit, as I understand it, and I am still learning a lot of things here, it's essentially asking hard questions, critical questions about quantitative methods from a social justice perspective, whether it's critical race theory, feminist, or intersectional perspective, whatever the case may be. It's asking hard questions about quote unquote objective quantitative methods. So we are developing a measure. And so let's think about some of the questions that you might ask, the critical, hard questions about classical quantitative methods that might be introducing bias, that might be exacerbating inequities. So one question you might ask is this, right? We took a grounded approach. So our very first step was to do focus groups, ask students, what does your instructor do or say? Well, if you just did this randomly, if you went to a random calculus class and you took a random sample of the students, who's going to show up to your focus groups? Well, it depends entirely on your institution, right? If you're at an HBCU and you go to a calculus class and you take a random, like everybody that shows up at the focus group is probably going to be African American. If you do it at Penn State, it's very likely there will be 0 African Americans that show up to your focus groups. In fact, if you do it at a place like Penn State randomly, right, it's very likely that 75% of your focus group participants are going to be white and Asian men, because that's what a random sample could easily look like at a place like Penn State. So what would be the consequences if you were to do that, right? Whose voices would dominate these data when you start to ask, what does your instructor do that makes you feel you belong, makes you feel you can succeed? If 75% of your focus group is white and Asian men, then those are the voices that are going to dominate those data. And then when you do the first step, right, you take all the things that the students say, you slap them into a big survey, those are going to be the voices that dominate the items in that first step and everything after that. And the question is, could this exacerbate inequity? Because, that 2010 study shows very clearly that the little boys and little girls in the elementary school study, right, they were in the same class, but they weren't experiencing it the same way. They weren't. They were having very different experiences. And so if you're doing focus groups and 75% are white and Asian men, those are dominating the data, right? What you're really going to be capturing here primarily are the things that white and Asian men feel their instructor does that makes them feel they belong and can succeed. And that might not be the same as what women feel or what our students of color, right? What their instructor does that makes them feel they can belong or can succeed. So we were very intentional about stratifying our focus groups. We did 6 focus groups. 2 of them were white and Asian men. 2 of them were women only. 2 of them were students of color only. And this, that's just the question that we ask all of these focus groups. And I want to share with you the variation that we got in the responses to that question from our focus groups. So we go to our focus groups, we list all of the things that people say, all the things the students say. My instructor does this, my instructor does that. And then we did a sort of thematic analysis of all the things that they reported. And what you're seeing here are the 4 most frequent themes. Okay, so the most frequent 2 themes where my instructor does this, that sort of promotes a growth mindset, or they have very good interpersonal skills. My instructor is good with one-on-one interactions, or actually not good with interactions was one of them, the negative version. My instructor engages all students, not just the kids in the front row or something. So these were the most frequent themes that came up. But what you see, right, is there's huge differences between what the white and Asian men were reporting and what the women and the students of color were reporting. In fact, the white and Asian men, the most frequent theme just for that demographic, for those 2 focus groups, was always related to performance. I feel I belong when I'm getting a good grade. I feel I can succeed when I'm succeeding, according to grades, right? It was very much tied to performance. That was the most frequent theme. The second most frequent theme, or frequently said thing amongst white and Asian men, and this was explicit: there's nothing my instructor does that makes me feel I belong or can succeed. And it was sort of the other side of the coin to the grades thing, right? For so many of them, their instructor, at least according to their reports, I'm not sure I believe all of them, but according to their reports, really what mattered to them in terms of belonging and success was their performance, and their instructor had very little to do with it. So if our focus groups had been, 75% white and Asian men, our data would have looked very, very different than it did, given our intentional stratification. Okay, anyway, step 2, right, that was to take all of the behaviors that were reported, slap them into a huge survey. We did that last year. We distributed it to about 870 STEM students, mostly here at Penn State. We were very intentional again in oversampling women. We wanted to make sure that women and students of color were well represented in our sample. At Penn State, it is possible to get 63% women. We had to work very hard, actually, to get 21% students of color. We are not a diverse campus, so that was a very difficult thing for us to do, and that will remain a limitation of this work. It probably would have been better if we were gathering those data from a more diverse campus. But in any case, we did what we could. And then we did our exploratory factor analyses and our item reduction. And what we have right now is a 28 item measure that has 6 factors. And we are still, mostly difficult for a black and white theoretical mathematician to do. And I don't mean that, I mean that very sincerely. Interpreting things causes me a lot of stress and grief because I don't know how to do it. I like things that are black and white, like a theorem. It's true or it's false. And that just doesn't happen in this world. And it's hard on me, but whatever. Woe is me, right? Poor guy. Anyway, we're not quite sure about the interpretations, but let me show you what we have at this point. Factor 1, we're calling helpful. You might see a couple of the sample items in this factor. My instructor explains things in different ways, or my instructor makes sure all questions get answered before moving on. Factor 2 is group work. My instructor encourages us to work in groups. My instructor checks in on us when we work in groups. The third factor is engaging versus disinterested. So for instance, my instructor talks enthusiastically about math. My instructor has little or no interest in student success. Fourth factor, actually this one seemed very impactful, came up in a couple different focus groups, and probably you guys have heard something like this yourselves from other students. You know, my calculus teacher is so brilliant. I'm sure they're amazing with graduate students, but they're just too advanced to be teaching this course. I don't quite know what to make of that one. I just feel like that is a really important one. And my gut feeling is that there's more to understand there, but I don't, at this point, we just have that as an item. My instructor is too advanced to be teaching this course. That was the direct report of the students. Another item in this factor is my instructor teaches too fast. Anyway, fifth factor, attention time management. My instructor pays more attention to some students than others. My instructor takes too long to return our stuff. And the final factor, which actually had a ton of items. Poor interpersonal skills. So for instance, my instructor smirks or laughs at our questions. My instructor says this material is simple, easy, or obvious. So these are our 4 factors, a couple of samples. And as I say, we are at the stage now of collecting data for confirmatory factor analyses and validity studies. So hopefully that work will go well. Hopefully we actually confirm the factor structure instead of the other. And if that does go well, then I hope this measure will be ready for research and formative feedback if individual instructors would like to get some formative feedback this fall. I will say I will be very disappointed if this measure is used for assessment of teaching in any way. I'm sure it's going to reflect the same sort of gender and racial bias that we see in teacher evaluations of other types. So I absolutely hope this is never used for evaluation of teaching, but I do hope it will be a useful tool for research projects and for formative feedback so that we can get a sense of how our students are experiencing our classrooms. So specifically, there's a number of research questions that are sort of on the horizon or in the future, and I would be very happy to get some help with any of these if anybody is interested. We've developed this in the context of mathematics, but if you look, actually, let me go back real quick. If you look here, like there's 4 items, and I think I'm right. Yeah, none of those have anything to do with math, right? You could ask those questions in a chemistry class. You could ask those questions in a physics class without changing them at all. There are a couple where you might have to tweak a little bit, but mostly this measure isn't math specific, even though it was developed there. So one of the research questions that I'd be very curious about, is it valid in physics and biology, in other disciplines? Can you find associations with student level variables, psychosocial variables? Can you find associations with student level academic outcomes? Is there variation? I mean, I absolutely expect that there is, but is there variation across students' identity markers? Because I don't believe, well, there's plenty of evidence that shows that women and men are not experiencing our classes the same way, right? Students of color and white students are not experiencing the class the same way. So I would expect variation according to various identity markers, including, and specifically when you take an intersectional perspective, I think we'll again see great variation. But another direction of research that I'm very curious about is how the students who are filling out this instructor behavior variable, like how or survey rather, how is that associated to instructor variables like the instructor's mindset? Or how about their discipline, right? Are averages like in math contexts and biology classes, are they the same? I'd be surprised, to be honest. I would absolutely expect that if you were to do large scale studies and let students in a bunch of calculus classes and students in a bunch of biology classes fill out instructor and inclusive instructor behavior surveys, I would guess we wouldn't expect the same averages according to discipline, but I don't know that. So that's a question I would be very interested in hearing in studying. So these are some research questions. And I just want to end this with a sort of thought and a question for everyone. So as I say, I don't know how to interpret the studies that we saw at the beginning in any other way, other than STEM ed, higher STEM ed is structurally racist and sexist. We are operating in an inequitable ecosystem. And so my question is, how do we, people doing, deeper work, how do we make sure that our work is dismantling those inequities as opposed to exacerbating them? And I really do mean that as a question, because I certainly don't have the answer to it. So yeah, I would be very happy to get feedback, or if, I don't know. I hope everybody will help me become a better researcher this way, and maybe even think a little bit more deeply, a little more critically about your own work if you're not already at this party. Because I think, we could all agree that it would just be terrible if our work was actually exacerbating inequities without our knowledge. Because just like with, manslaughter and murder, our intentions are really irrelevant, right? What matters is what's happening in our classes, what's happening with our work. And so I hope we can all try to think about this question: how do we make sure that our research is shrinking equity gaps, not making them bigger? So with that, I will close, and thank you all very much for your time. It's been wonderful. So thank y'all.
Thank you.
Well, I think we have a few minutes for questions, right? So if you have a question, feel free to raise your hand or jump in. And thank you, Nate. That was really wonderful. Thank you.
I saw a few hands up.
I think those are the.
Oh, they're clapping, okay.
I can ask one to get us, or Sam, you unmuted yourself. Sorry, go ahead.
Okay. Great. I really liked what you said there. And just 2 weeks ago, I attended the ONR UIM student education project as nationwide project. And about 5 ONR program officers were there, with 13 institutions from the country. Actually, I presented your Lexis paper, last year's paper, in that workshop. And so what we concluded one thing is that, or a couple of things. One, you said that we may not be a racist, but many of us are protecting a racist system. So that's one conclusion. One language said, another one says that actually CSU San Marcos here, you said that they are ranked #1 in social mobility. That means that's the term I learned from there, is that actually students can go from one class to the next class rather than to keep it rigid. This is very relevant to your kind of open-minded, growth-minded to the mindset. And third sentence I learned is that I cannot be if I cannot see. So that means those will be the set up examples for minority students. That's respond to your mind, to your sense of belongings. So thank you very much.
Thank you.
I have a question, Nate. Great talk, by the way. Love it. And the gentleman who just spoke, Sam Shem, is our former department chair in mathematics. He's a research mathematician. So I'm glad to see you here, Sam. Thanks. So I guess it was maybe 7 or 8 years ago, Francis Su has an article on mathematical microaggressions. And I feel like your last category, your factor on interpersonal, I forget, whatever the term was, right, maybe lends itself to mathematical microaggressions. And I was wondering if you thought about ways in which those do have a mathematical specific things. Like I'm thinking like in mathematics, oh, this is obvious. It probably doesn't happen in chemistry very often. And so I just want to hear your thoughts about maybe that factor does have some mathematical aspects to it.
And that's a very good point. That's a very good point. And so the question about whether this measure is valid in other disciplines is a genuine question, because it could be that factor just doesn't show up when if you were to distribute the measure as we have it today. If you went to a chemistry class or biology class, it very well could be that factor just doesn't show up, because that might be specific to mathematics. I guess the thing I was trying to emphasize was that the wording of the questions, for most of them, isn't math specific. It could be that the content of the questions is math specific, but the wording isn't. So there's I don't think it's a heavy lift to adapt this to a chemistry class or a biology class or something. But you're absolutely right. I actually wasn't aware of that paper of Francis Sue, I'll have to look that up. Mathematical microaggressions, huh?
Yeah, I think it's in the focus, maybe 2014, 2015. Probably Sandra knows off the top of her head.
I'll find it. That's
Yeah.
terrific.
Good.
Thanks.
Colin has a question in the chat.
Oh, thank
That up
you.
and take a look.
I will read what Colin wrote. Says, a bit loud in my apartment right now. Neil is playing the drums, so I'll type mine out. A comment. I really enjoyed your shared, how you shared your journey towards using critical theory in education research. It was very genuine and demonstrates your passion for equitable experiences for your students. I think it is also a great model for other instructors and researchers as they may see a part of themselves within your story. You could very well inspire other mathematicians to grow and learn in the same ways that you have, with a smiley face emoji. So.
Thank you, Colin. I appreciate that. And yeah, I certainly hope you're right about that. I mean, I think it's important for all of us to normalize our imperfections, because I don't know anybody who's perfect. And so being vulnerable and being able to stand up and say, yeah, I sure wish I would have done that differently. I hope that makes it a little easier for other people to make some changes, because we're all on a journey. We're all on a path towards whatever enlightenment means to you. And so, yeah, I appreciate that. And I hope you're right.
If nobody asks, I will ask. If other people ask, I will stop. Yes, okay. So now I mean, just say, I probably say we just is I read a lot of papers on education and chronicle higher education. I read several of yours, and we talk a lot about problems, and I'm more into looking for solutions. So what I've been doing, I want to introduce, that's what I'm doing now, the kind of progressive education pedagogy to mathematics and science. How do you think about that method, progressive education pedagogy?
I am unfamiliar with it. So yeah, I'd be happy to learn. If you have a resource or something you could send me, I'd love to learn more about it. So I'm sorry, I can't answer your question, but that's the best I can say. As I say, I am not yet an education expert. I am very much in the process of learning this. So I appreciate you bringing that to my into my realm so I can learn something.
I will email you. We'll have a discussion. I read several pages. Yeah.
Terrific. Thank you very much.
Sandra also unmuted. Sandra, do you want to jump in?
Sure. Thanks for the talk, Nate. Sandra Larson at Colorado Boulder. This is not a well-formed question, but one reaction I have a little bit to your 6 factors is it's a fairly low bar, and that's maybe connected to your pragmatic goals, but it makes me a little sad to think a lot of students don't even see a faculty member who's excited about their discipline or who answers their questions or pays attention to them. And so could you comment on that? Like, do you think this will really, I don't know, how would you like to see this change the behavior?
So that's a hard question. That's a hard question, but let me address the first bit of it, and then I'll come back to how I hope it will be used and make some changes. One of the limitations of this work is that it was done at Penn State in our calculus classes, which are small, relatively small, 45, 50 students, not 100 student, lecture halls. So we have a lot of faculty teaching this, but relatively few, almost none actually in the calculus sequence, are using anything other than traditional Sage on the Stage lecture. So the sample, the students that reported to us, they weren't seeing progressive teaching methods at all. They're really just reporting what happens in a traditional monologue lecture, and that's a limitation. So it would be very interesting to redo this whole project with a greater variety of a greater variety of class teaching methodologies and so on, because I would guess that the items we get would be very different, and hopefully the bar would be raised a little bit if we were to do that. So there's that. And then the other point is that I really become quite I don't know, obsessed maybe is a little strong, but really think a lot about emotions and psychology. And it's so funny because my whole career, like first half of my career, I was 100% on board with the idea that real learning, deep learning, difficult learning required that you push all your emotions to the side. Get them out of the way. Like you can't learn anything if your brain is confused with it. Like that's how I felt. And now I know I was exactly wrong about all of that. And now neuroscientists have actually shown that emotion is a key ingredient to deep learning and understanding and knowledge. So anyway, that's just to say that I personally hope that the measure that we develop, if nothing else, it will just raise awareness and lead to better training of our graduate students, of our faculty around emotional, psychological components of teaching, because I'm a research mathematician, and I can assure you when I was a grad student and all my colleagues that I interacted with at conferences and so on, we all genuinely believe that good math instruction is all about the math, nothing else, right? It's just about the math. Emotions have nothing to do with it. How I interact with you has nothing to do with it. If I dismiss your question, that shouldn't bother you. It's just about the math. And if we could get rid of that misguided, that's the most polite way I could put it, that misguided philosophy, I would be thrilled. And I hope that this work will sort of contribute to that.
Thanks.
Great. Well, I see that Colin had put a link into the focus article. Thanks, Colin. That was quick work of you. So if anyone wants to go to the chat, you can find Francis Su's article on mathematical migrations. Please join me again in thanking Nate. Great to have a virtual talk. Thanks. Wish you could have been here, but this is the next best thing. Thanks so much, Nate.
Thank you. And again, it was a pleasure. Hope to meet you all in person someday soon.
Yeah, please come visit us, and I can leave the room open, but let's make sure if folks have to move on, they can have a good place to go. So have a good afternoon, everybody.
All right. Thank you. See you, Colin's child.
Yeah. Little Colin.
Have a great day.
Okay, bye-bye.